Children, I welcome all of you to the world of statistics. Under statistics, so far we have studied about the basic terminologies and about the frequency distribution table. Now let us study about one of the fascinating methods of representing data through colorful histogram. Children, look at the queue in front of the zoo garden. How eager the children must be to get inside the thrilling world of birds and animals. Oh, there are children of different age group. The histogram represents the graph of age group against the number of students. Without counting the number of children of different age group who visited the zoo, will you be able to tell which group of children visited the zoo? Yes. First one, the highest number. Second one, least number. Yes. It is very easy. The heights of rectangles tell us the answer. First one, from the graph, we find that the age group of children between 9 to 10 is the highest, that is 100. And children of age group of 8 to 9 is the least, that is 25. Very good, children. Keep it up. Do you know what these rectangles are known as? The rectangles which stand side by side is called a histogram. Then, what is a histogram? So, a histogram is a graphical representation of a frequency distribution by means of rectangles whose width represent class intervals and whose areas are proportional to the corresponding frequencies. Take down this definition in your notebook. The word histogram was derived from the Greek histos, which means anything set upright, and gramma, which means drawing record, writing. The term was introduced by Carl Pearson in 1895. Children, to follow this, we shall take up an example. Here is an example. Draw a histogram to represent the following frequency distribution. And here, class interval and frequency are given. From 20 to 25, the frequency is 5. Between 25 to 30, the frequency is 10. Between 30 to 35, the frequency is 18. Between 35 to 40, the frequency is 14. Between 40 to 45, the frequency is 12. In step 1, on a sheet of paper or a graph sheet, draw two mutually perpendicular lines to represent x-axis and y-axis. Now we shall get into step 2. Choose a suitable scale to represent the class intervals and the frequencies. Now I have taken the scale here on x-axis. Let 1 centimeter is equal to 5. That is width of class intervals. On y-axis, let 1 centimeter is equal to 2 units. We shall represent frequencies on this. Since the class interval for the given distribution start from 20 to 25, mark a kink near the origin. Mark the lower limits 20, 25, etc. on the x-axis and the frequencies 2, 4, 6, 8, 10, etc. on the y-axis. Now we shall get into step 3. Draw a rectangle of width 5 centimeter, that is size of the class interval, and of the height 5 centimeter, that is frequency of the class interval 20 to 25. Similarly, draw the rectangles without gaps for the other class intervals. That is, between 25 to 30, the frequency is 10. So, the width will be 5 centimeter and the height will be 10 centimeter. Now, let me go to the next class interval, that is 30 to 35. What is the height? You are exactly right. That is 18 units you have to go. Then, the class interval 35 to 40. So, the height will be 14 units. In the same way, the class interval 40 to 45, the height will be 12 units. Now, we have drawn the histogram for an exclusive type of distribution. Here is a note about the kink. When the class intervals do not start from 0, show the gap on the x-axis by a kink or break of a zigzag curve near the origin. Note, the width of the rectangles represent the corresponding class interval, whereas the height of the rectangles represent the corresponding frequency. There should be no gaps between rectangles because the scores are continuous. The width of bars should be same when the size of class interval is constant. Children, remember that in an inclusive type of distribution, the scores are not continuous and hence we cannot draw rectangles adjacent to each other. This means they become a bar graph rather than a histogram. Hence, first we have to convert the inclusive form to exclusive form of distribution. Here is the procedure. That is, procedure to convert from inclusive to exclusive form. Look at this class interval given in this table. That is 10 to 19, then 20 to 29, 30 to 39, 40 to 49, 50 to 59. What type of class interval it is? You are right, it is inclusive type of class interval. So it should be converted to exclusive type of class interval. How it is converted? We have to subtract 0.5 from the lower limit and add 0.5 to the upper limit of the class interval. So we have to find the correction factor here. Yes, it is d by 2, where d is nothing but lower limit of class interval minus upper limit of class interval before it. Consider the class interval 20 to 29 and 30 to 39. Yes, here d equals, what is d here? You are right, it is a correction factor. That is 30 minus 29. That is equal to 1. Then what is d by 2? You are right, it is 1 by 2, which is equal to 0.5. So this shows that we have to subtract 0.5 from the lower end and we have to add 0.5 to the upper end to convert the inclusive class interval into exclusive class interval. Prepare a frequency distribution table with true or actual class limits. Actual lower class limit of 10 to 19 is got by subtracting 0.5 from 10. Actual upper limit of 10 to 19 is got by adding 0.5 to 19. Hence, the actual class interval of 10 to 19 is, yes, you are right, that is 9.5 to 19.5. Now, we shall draw the histogram for the given data. The data is between 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, and the respective frequency is given in the third column. What we have done here is convert the given inclusive class interval into actual exclusive class interval. How will you convert it now? Yes, we have to take the correction factor. We took the correction factor, and the correction factor is d, which is equal to 1. What is d by 2? It is 1 by 2, that is 0.5. That shows we have to subtract 0.5 from the lower end and add 0.5 from the upper end. Then 10 will become 9.5, 19 will be 19.5, and the frequency is written as it is. Between 20 to 29, subtract 0.5 from the lower end, add 0.5 to the upper end. So we will get 19.5 to 29.5, and the frequency is 10. 30 to 39. So if you subtract 0.5 from the lower end and add 0.5 to the upper end, it will be 29.5 to 39.5. In the same way, for 40 to 49, it will be 39.5 to 49.5. In the same way, for 50 to 59, you are right, it is 49.5 to 59.5, and the respective frequency is written. Now we shall take up this data to draw the histogram. Okay? We shall take the convenient scale. On x-axis, 1 centimeter is equal to 10 units, and on the y-axis, 1 centimeter is equal to 2 units. The x-axis represents the class interval, whereas y-axis represents the frequency. Now leave 0.5 because the class interval is not commencing from 0. So between 9.5 to 19.5, the frequency is 7. Therefore, draw a rectangle of height 7 units and width, you are right, that is 10 units. In the same way, get into the next class interval. The next class interval is 19.5 to 29.5. So, as usual, the width is 10 units, whereas the height is 10 units. Now, the next class interval is 29.5 to 39.5. So, we have to take the height of this rectangle. You are right, that is 20 units. Next rectangle, 39.5 to 49.5. So, we have to go to the height of 5 units and complete the rectangle. So, for the next class interval, 49.5 to 59.5. So, the height will be 15 units. So, this is the histogram that we get for the given data. Children, now we shall get into the next practice problem. Draw a histogram for the following frequency distribution. Class interval and frequency are given. Children, look at the class interval. What type of class interval it is? You are exactly right. This is an inclusive class interval. So, we have to convert this inclusive class interval into exclusive class interval. That is, we have to find the correction factor first. Yes, what is the correction factor? The correction factor is, we shall take up some class interval, that is 11 to 20 and 21 to 30. D will be 21 minus 20, the difference is 1. Therefore, D by 2, that is equal to 1 by 2, that is equal to 0.5. This shows, to convert this class interval into exclusive class interval, we have to subtract 0.5 from the lower limit of the class interval, and you have to add 0.5 to the upper limit of the class interval. Shall we do it now? Okay. The given class interval is 0 to 10. Subtract 0.5 from 0. It is minus 0.5. Add 0.5 to the upper limit 10. It is 10.5. write the respective frequency, and that is 4. Yes, next is 11 to 20. So by subtracting 0.5 from the lower end and adding 0.5 to the upper end, you will get 10.5 to 20.5. The frequency is given, it is 18. In the same way, 21 to 30, 20.5, 30.5, and the frequency is 12. 31 to 40, 30.5 to 40.5, and the frequency is 6. 41 to 50, yes, you are right. Subtract 0.5 from 41. Add 0.5 to the upper end, 50. You will get 40.5 to 50.5, and the frequency is 20. In the same way, for 51 to 60, you are right. You have already written it. 50.5 to 60.5, and it is 10. What we have to do? You are exactly correct. First, we have to write x and y axis and take the convenient scale, mark the kings on it. The convenient scale is on x axis, 1 centimeter is equal to 10 units. On y axis, 1 centimeter is equal to 2 units, because all the numbers and the frequency, they are divisible by 2 easily. Now, we shall draw the histogram. The first class interval is minus 0.5 to 10.5. So, minus 0.5 means 0.5 units left from the origin. Now, the width is marked, that is between minus 0.5 to 10.5, and the height is 4 units. Now, we got a rectangle, complete the rectangle, get into the next class interval. It is 10.5 to 20.5. You have marked the kink already on the x-axis. Now you know the width of the rectangle. The height is given. It is 18 units. So you have to take 18 units height and complete the rectangle. Follow the same procedure. Get into the next class interval. It is 20.5 to 30.5. What is the height given, children? You are right. It is 12 units. So complete the rectangle. Now we shall get into the next class interval, 30.5 to 40.5. Yes, we get the rectangle, taking the height 6 units. Be fast, complete the rectangle. The next class interval is 40.5 to 50.5. What is the height given? Yes, it is 20 units. We will get a big rectangle. Complete the rectangle now. Yes, it is over. We shall get into the next class interval, 50.5 to 60.5. Go to the height of 10 units and complete the rectangle. Show me the histograms. All of you have drawn the histogram? Yes, children, it is right. Excellently drawn. Very good. Shall we take up another practice problem? Is it interesting? Very good. Draw a histogram to represent the following frequency distribution. Class interval and frequency are mentioned here in the frequency distribution table. By looking at the class interval, you can decide what type of class interval it is. Anybody? Yes, it is correct. It is exclusive class interval. So, we need not to convert this class interval. It's already given as exclusive class interval. Directly you can draw the histogram. What is the next procedure to draw the histogram? You are right. Draw x and y axis. Now we shall take up the convenient scale. On x axis, 1 centimeter is equal to 10 units. On y axis, 1 centimeter is equal to 2 units, because all these numbers are divisible by 2 easily. Shall we plot the histogram now? Yes, between 5 to 15, the height will be 2 units, and complete the rectangle. Get into the next one. Between 15 to 25, the height will be 8 units. You are all plotting? Correct. At 15 also you have to take 8. At 25 also you have to take 8 units and complete the rectangle. Follow the same procedure. 25 to 35, the height will be 14 units. And even for 35 to 45, the height will be same, that is 14 units. And between 45 to 55, the height is 12 units. Yes? Is it over? Excellent. Now we get the colorful histogram. The maximum height is 14 units. And two class intervals have the maximum height 14 units, that is 25 to 35 and 35 to 45. Children, if the class intervals are exclusive, it is easy to draw the histogram. So, if there are inclusive class intervals, we have to convert them into exclusive class interval and draw the histogram. Children, under statistics, so far we have studied about construction of histogram. In the next capsule, we will be studying about the measures of central tendency. Thank you, children.